Okay, these are our notes on rocks and weathering. What is erosion? Erosion is the process by which water, ice, wind, or gravity moves fragments of rock and soil from one place to another. The actual movement of the particles is the erosion. What is weathering? Weathering is the breakdown of rock into smaller pieces by heat, cold, water, ice, and gases. Okay, where they actually just break apart, but there's no movement. Okay, like this rock splitting in half. It just broke. It didn't move. Erosion is moving. Weathering is breaking apart. Okay, here's Mount Rushmore. Down at the bottom of Mount Rushmore, there's a pile of weathered material at the bottom. It is slowly beginning to erode, or it's slowly eroding down the hill by gravity. And it will not be there forever because it will get weathered away. It will take a long time, but it will get weathered away. So key point, if a particle is loosened by weathering but stays put, it's just weathering. If it starts moving by wind, rain, it's erosion. Okay, remember that. There's a difference between the two. Now we're going to talk about the types of mechanical weathering. Mechanical weathering is a process by which rocks are broken down into smaller pieces by external conditions. Examples of the external conditions could be animal actions, freezing and thawing, or frost wedging and heaving is another name for it, plant growth, release and pressure, and abrasion. Frost wedging is the freezing and thawing of water in cracks. So you have a crack in a rock, the water gets down into it, and then in the winter it freezes and it spreads apart that crack, making it larger than what it was. Then the water melts away when summer comes back around, and then it's left this open, or this larger crack than it was the previous season. Then we have plant growth and roots. Plants and roots and trees can enter the cracks in the rocks as they grow. The force cracks apart the rock over time, and these plants can pry apart the rock with their roots. Okay, I'm sure you've seen before a rock growing within a tree, especially if you've been down to like Hocking Hills, where they have lots of trees growing off of cliffs. You can see this right here in Findlay, Ohio, too, where you've got plants growing up in between rocks and breaking up sidewalks with roots from the trees. It's here. It's visible. You see it all around you. This is an example here and here. Abrasion is the wearing away of rock by other rock particles carried by wind, gravity, ice, or water. If any of you have ever been out west is a great place for abrasion to occur because it's so flat. Winds get carrying sediments and they go for a long time and they go very fast. And when they do eventually hit a rock, then they can hit it for a long time over and over again, and it's going to drill in a hole. It's going to take a very long time for a formation like this to occur, but that's caused by abrasion. It's like sandblasting, okay, or sandblasting that rock. Same with this one down here. Okay, the wind has been pummeling it for many years with sediments and sands and forming it into that shape. Animal actions. Animal actions help to loosen and break up rocks in the soil. Animals that burrow down and break up rock include gophers, prairie dogs, moles, insects. These are just some examples of animals that would cause the weathering of a rock. Then we have chemical weathering. Chemical weathering is a process that breaks down the rock through chemical changes. Okay, so the agent of a chemical weathering would be water, oxygen, carbon dioxide, living organisms, and acid rain. How water chemically weathers rock is by dissolving it. Okay, water can also carry other substances that dissolve or break down the rock, such as oxygen, carbon dioxide, and other chemicals. Okay, so we can see this puddle, water has been sitting here for a long time, and it's worn away at the rock just by sitting on it. Oxygen. Iron combines with oxygen in the presence of water in a process called oxidation. Okay, we've talked about oxidation before when we talked about rusting and we talked about chemical changes. Okay, this is the same kind of chemical change. The product of oxidation is rust. Okay, sometimes you've seen in rocks like a streak of rust that's reacted with reacted with oxygen. Then we have carbon dioxide. CO2 dissolves in rainwater and creates carbonic acid. Carbonic acid easily weathers limestone and marble. Okay, so down in the water, it'll mix with carbon dioxide, and then it makes an acid that will wear away at certain rocks because of their chemical composition. Then we have acid rain. Burning coal, oil, and gases pollute the air with sulfur, carbon, and nitrogen compounds. These compounds react with water vapor in clouds, creating acids stronger than natural rainwater. These acids mix with raindrops and fall as acid rain. Acid rain causes accelerated chemical weathering of rocks. Okay, so the more acidic your rain is as it falls on a rock, the more weathering will occur to the surface of a rock. And the less acidic it is, then you're not going to have as much weathering occurring. Then we have living organisms. Lichens that grow in rocks produce weak acids that chemically weather and break down rock. Okay, these green things here, these are the lichens. Okay, I know you've seen them before. Okay, but they will chemically break down a rock. I mean, it would take a long time, but that's what's occurring there. Factors affecting weathering. The type of rock. Rocks made of minerals that do not dissolve easily will weather slowly. Rocks that are permeable, meaning it has holes in it, tiny little air spaces that allow water to seep through, carrying chemicals into it, will dissolve quicker because they've got all that, the water can get in easily with the chemicals, and that will let it dissolve quicker. And then we have climate. Climate plays a factor because the warmer, wetter climates weather faster due to their high temperatures and high moisture in the air. Okay, and so here we can see this has been weathered very much. And one of the examples in the book was talking about tombstones. Okay, some tombstones will last much better if they're in a climate that is less wet and it's cooler, so that it doesn't weather as quickly and wouldn't have as much acidic acid rain. Also depends on what you make the tombstone out of. You're not going to see tombstones made out of permeable rocks, okay, ones with air holes in them, because they won't hold up. Make sure that you have filled out all of your notes, and if you have any questions, please make sure that you ask me in class.